So in this video, we're gonna talk about naming or cycloalkenes. Now, one thing I need you to remember is that for cyclic alkenes, the alkene carbon always gets number one. So let's jump straight into an example. And what do we actually mean? So you're given this molecule on an exam. How would you name it? Well, again, the parent, the first thing we're going to do is name the parent, or the longest continuous carbon chain. So this is a cyclohexane ring. But because we have an alkene, this would be a cyclohexene as the parent because it has a double bond. So it is a cyclohexene. Now, how do we label? Remember, the alkene, you have to count across the alkene double bond with still keeping in mind that the substituents get in the lowest number possible. All right, so if I label this as carbon 1, 2, 3, 4, 5, 6, then you could see that as a substituent, on carbon 3, I have a 3-bromo as a substituent. Now, you may be saying to yourself, why couldn't I have labeled as 1, 2, 3, 4, 5, 6? And the idea why the green is incorrect is because now I'm giving the bromo position 6 as opposed to position 3. Right? So this is why the first way that we counted would be the correct way. Keeping in mind that the alkene double bond always get in carbon, you always label it as carbon number 1. So if you put this together, then we have a 3-bromo cyclohexene. This is a terrible way to write hexene, but you get the idea. So pretty nice and simple. Let's go to something more difficult. What if you're given this molecule on an exam? How do you name it? Well, again, the alkene carbon always gets the lowest number, carbon number 1, but you could actually see that we have really 2 alkene carbons. So where do we start? Do we start on the left side or the right side? And the idea here is I'm going to start on the left side as 1, 2, 3, 4, 5, 6. The reason why I did that is because if I had counted from, let's do the substituents first. So the parent in this case would be a cyclohexene again, right? Because again, it will be a cyclohexene because again, there's a 6-carbon chain with an alkene in the ring. Now, what are the substituents? On carbon 3, we have a methyl group, so this is 3-methyl. But we also have another methyl group. We have 2, so this is 3-methyl as well. And then on carbon 6, we have a methyl group, so this is 6-methyl. Now, had we had counted like this, let's say this now becomes carbon 1, 2, 3, 4, 5, 6. Now I'm going to have 2 6-methyl groups. All right, so I'm going to have 2 methyl groups that would be labeled 6 instead of having 2 methyl groups that would be labeled 3. All right, so therefore, again, this would be incorrect. The green way would be incorrect because, again, we're giving our substituents a higher number. Again, the goal is to give our substituents the lowest number possible. So if we put this together, then this becomes 3, 3, 6 dash. We have to use a prefix because we have 3 methyl groups. So 3,3,6 dash trimethyl cyclohexene. So this would be your IUPAC name for this molecule. How about this one? The first thing I'm going to do is the parent. Longest continuous carbon chain. So this is a pentane ring because it's 5 carbons. So this is a cyclopentene. We have to use that ene for alkene. So this would be a cyclopentene. Now, how do we label it? How do we count our carbon atoms? Well, if I start from here, it becomes 1, 2, 3, 4, 5. Okay? So on carbon 3, or substituents, then would be that on carbon 3 we have a 3-methyl, and on carbon 5 we have a 5-methyl. Right? If we had counted from this perspective, so let's say this becomes carbon 1, 2, you would actually see that it does not matter. 3, 4, 5. So in this case, we got lucky that it does not matter which way we count, because again, the substituents are going to get the same number. So this is a special case. So if we put the name of the molecule together, this becomes 3, 5 dash. We have to use a prefix now, dimethyl, because we have two methyl groups. Cycloalkenes. So this would be the IUPAC name for this molecule. Let's try another one. How do we label this one? Pause the video and try this one. So in this case, the parent, you have to be careful now. The parent is a cyclohexa, so let me delete this. So the parent would be cyclohexadiene, because we have two alkenes, right? So we have to have that diene, right? If it was a pentane ring with two alkene or two double bonds, it would be cyclopentene or cyclopentadiene. Now, because we have two double bonds, we have to label our double bonds accordingly. So where would we start counting from? Well, I'm going to start counting from here. So this would be carbon 1, 2, 3, 4, 5, 6. And then I'm going to show you why I started counting from there. Now, anytime you have more than one alkene in a ring, you have to label the positions that they're at. All right, so the first alkene starts at carbon number 1, so this would be 1. And the second alkene starts at carbon number 3, so this would be 1,3-cyclohexadiene as the parent. The substituents, we have, on carbon 5, we have a bromo, so this is 5-bromo. Now, what is incorrect is that if I had started from here, so let's say in the blue, I did 1, 2, 3, 4, 5, 6. The reason why the blue in this case would be incorrect is because now, instead of having 5 bromo, I have 6 bromo, right? So again, I'm not giving the substituents the lowest number possible. So that's why the blue labeling would be incorrect. And any other labeling that you do would be also incorrect, because again, you're giving the substituents a high number. So in this case, putting this all together, we say we have a 5-bromo dash 1,3 dash cyclohexadiene. This would be the IUPAC name for this molecule. What about this one? How to name this molecule? Well, the parent in this case would be the longest continuous carbon chain. So this would be 1, 2, 3, 4, 5, 6, 7, 8. All right. So in this case, this would be octene, but because we have two double bonds, we have to say this is a octadiene. Now, because we have two double bonds, we have to label the carbon on which they occur. So we have one on carbon 2, and we also have one on carbon 4. So this would be 2,4-octadiene. Now the substituents is that on carbon 6 we have a pentane ring. So as a substituent, it becomes cyclopentyl. Right? So instead of a cyclopentane as a substituent, it becomes cyclopentyl. So if we put the name together, then we essentially have the substituents first, which is 6-cyclopentyl dash 2,4 dash octadiene. And this is how we label cyclic alkenes, ladies and gentlemen. Notice that the last one was not cyclic though, but again, we have to throw a little bit of tricks and trade into the videos.